Hello and welcome back. And in this video, we're going to be looking at another interview question. And this one, once again, is related to stack. And the question goes, you need to remove k digits. So basically, you've been given a non-negative integer number in a string format, right, represented as a string. And you need to remove k digits from the number so that the new number is as small as possible, right? So, for example, if you have 1, 2, 3, 4, and you've been given that remove k is equal to 1, so remove 1, that means from 1, 2, 3, 4, if you remove 4, you get 1, 2, 3, which is the smallest possible digit in that number that you can form with that. So the length of the number, again, is basically 10,002. So that's actually given, and the k's value is definitely going to be will be greater than I think it should say 1, greater than or equal to 1, and the given number does not contain any leading zeros. So the given number does not have any leading zeros, and when you return an output or response, you should not contain 0 as well. That's not given, but that's kind of understood, from this example. So let's take a look at the example. So you have like this number 1432219, and k is equal to 3. If you look at this number, the smallest possible number that you can form with this number is 1219 by removing 3 digits from this. Okay, and if you look at another example, you have 10200, and there's an explanation here, which is it to remove, so you can actually read that one. But it's actually if you remove the largest digits, like 432, if you remove these three, then you have 1219. Let's take a look at another example, 10200, and k is equal to 1. Clearly, if you remove this 1, right, it becomes 0200, which essentially is 200. And then you have this number 10, and you remove 2 digits. That means you have the output as 0 because you have removed both of these digits, so nothing is left. Okay, so that is the question. Once again, it can be solved using stack, and it can be solved without using stack. So we're going to take a look at both variations in subsequent videos. Excuse me. So what I would recommend is pausing this video here and taking a first stab at building basically the algorithm, and then you can come back and check out what we've got for you here. Okay, so pause the video now. All right, I hope that went well. So let's go ahead and take a look at our solution. So first, let's understand how we can actually solve this problem. So if let's say you've been given number 1, 2, 3, 4, right? And if you have 1, 2, 3, 4, what are the possible combination of digits you can make if you had k is equal to 1, right? So you remove 1, and then what are you left with? So if in 1, 2, 3, 4, if you remove 1, you're left with 2, 3, 4. If you remove 2, then you are left with 1, 3, 4, and if you remove 3, you are left with 1, 2, 4, and if you remove 4, you're left with 1, 2, 3. Now, in this set, you can clearly see that all these numbers are bigger than 1, 2, 3, so 1, 2, 3 is the smallest number. The other thing that you would notice is if the numbers are in sorted order, that means removing last digit gives you the smallest possible number, right? So that's one hypothesis you can actually go after. Okay, let's take a look at another example. 2134. Okay, k once again is equal to 1. Okay, now we can actually take a look at follow the same logic. So we have 2134. We can get 134 with this. We can get 234 with this, right? By removing 134 by removing 2. So remove 2, and 234 remove 1, and then you remove 3, that means 2 and 4. Okay, you remove 3, and you remove 4 is 2 and 3. Right, now you can see clearly that this one has 134 as the smallest possible number. So if you try to see a common pattern here, you would notice that the number, if let's say you're iterating on each number, right? If the number that is current is smaller than the previous number, right? Then you know that this number leading, starting from this number to the remaining string or remaining number, the combination is going to be smaller because this makes that number large. So if you remove this, let's say k was 4, for example. Oh, sorry, k was 2. Okay, so you need to remove 2 digits. Now, if you remove 2, because 2 is greater than 1 here, so if you remove that one and you move the last one because now it's sorted, you are left with 13, which actually is the correct answer because 13 is the smallest possible number that you can make out of this 2134 digit by removing 2 digits. Okay, so that's the basic idea that we're going to go after, right? And we're going to try to see, if we can put this in stack and see how stack actually helps us. So let's create a function, remove k. You're going to take a string. You're going to take a number, or basically k, and we're going to return a string as well. All right. Now, there are a few things we're going to need. We're going to first need stack. Stack is going to be of character type. Then we're going to need a size array. So this is going to be, size variable. And this size is going to be basically str.count minus k. So basically we can use this size for our sorted case. So let's say if you had 1, 2, 3, 4, for example, as an input, and size was given as k, right? In that case, we know that the entire string is going to go through for the other condition where we are checking if the current number is smaller than the previous number. So we're going to go through this entire entire string, passing that condition. So 1 is not smaller, 1 is not greater than 2, 2 is not greater than 3, 3 is not greater than 4. So we're going to go through that, right? So in order to handle that edge case of having the number sorted, we're going to use this size variable to truncate the items from the back. That is going to give us the smallest possible number from that string. Okay, we're going to just cache k as local variable just so we can operate on it, and that's about it. So if we run our loop and for each character in the string, and now what we need to do is we need to actually put a while loop here, and we need to put a while loop to make sure that we check our k is basically, first of all, is greater than 0, right? And your stack is not empty, so stack count is greater than 0. These two conditions first needs to be checked. Then we check if the stack dot last item that was inserted is greater than the current character we are iterating over. Now this is not possible because both of them are characters, so let's create a helper function that is going to help us convert character to int, and we're going to take character as an input and as a parameter and return integer. We're going to convert our character into string and then cast it. Try to basically get a string int out of it, integer out of it. Okay, so you're going to use this guy right here to basically wrap around our stack's last value. So once again, what this line is doing is basically comparing that 2, 1, 3, 4 case, right? So it's comparing if the last item in the stack that was inserted, so let's say if we start from here, 2 was inserted in the stack, and now we have 1, our k is still greater than 0. That means we haven't removed digits yet. Our stack count is greater than 0 because we have at least one item in the stack. Now we are sitting at 1. So we look at stack.last, so that's 2, and it is greater than 1, right? So what we want to do is we want to remove that element from the stack. So stack.remove last, okay? And we also want to decrement our k by 1, okay? Because we have removed one digit, okay? Now let's say if this was 4 and 3, okay? And we had k is equal to 2. In the next iteration, so 2 is gone from the stack, so stack is empty now. In the next iteration, and we come out of the iteration and we append stack.append that character, right? So 1 is gone into the stack. Next item is 4. So we are iterating over 4 now, and we say is last item of the stack greater than the current? No. Insert it into the stack. Okay. Now we are at 3. So we compare again. We say if 4 is greater than 3. Yes, it is. That means we need to remove 4, right? And then what we need to do is we need to decrement k. Now k was 1 because earlier we removed one item. So k was originally k was 2. So k's value was 2, right? So you removed 2 first. So in 2, 1, 4, 3, we removed 2 first. So k's value became 1. And then you removed 4, and k's value became 0, right? So now this condition is gonna this condition is gonna fail. So it's gonna return false, right? Because k is not greater than 0 anymore. So we are gonna continue to append remaining characters. So if you had more characters, we can actually append it. And that's gonna actually form us a smallest possible number. Okay. Now we are past that loop, so we have something in stack. So first thing we're gonna do is we're gonna compare. We're gonna get the value from the stack. We're gonna say stack. So now basically we need to check for if the stack is greater than 0. So if the stack does not have anything, so we ended up removing everything. So if stack dot count is less than equal to 0, right? In that case, we're gonna simply return 0. Okay. If that's not the case, and if we proceed, that means we have something in the stack. So what we want to do is we want to actually get the result in an array. So stack is an array, right? And what we need to do, we need to cover that condition of 1, 2, 3, 4. Okay. So let's say if your input was 1, 2, 3, 4 and k was 1, in that case, you know that this condition has passed through. So none of the elements in that string 1, 2, 3, 4 have been removed because everything satisfies that greater than test 1, 2, 3, 4. Right? So your stack has 1, 2, 3, 4. Now you know what to do when you have values sorted incrementally. So in that case, you remove the number of k elements from the back, right? So that's what we're gonna do. We're gonna say stack takes 0 and basically take all the elements less than size that we have actually computed here. Okay, now we have those this new array that actually contains, let's say if the k was 1, then only contains the final result, which is the lowest possible number that can be made out of that string 1, 2, 3. Okay, so we can actually sort of convert it into a string, okay, like that, and that's going to give us a string representation. And in order to in order to avoid this situation where you have 0, 0, 200, for example, remains in the stack. If, for example, if this was your result and you had ended up removing 1, let's say if this was 1 and you just had to remove 1 to make it small. If you remove 1 digit, this 1, then it's 0, 0, 200, which means it's 200. So what we need to do is we need to actually convert this result into an int. So return integer representation of that result, so it can remove all the leading zeros, right? And because our output actually expects to be returned as string, we can string interpolate here, and we can simply say this. Okay. So with that said, let's go ahead and run this. So I'm going to actually say 1, 2, 3, 4, 5, 1, and yeah, these are good examples. So let's go ahead and run this. So there we go. We have 1, 2, 3, 4. We know because that number is sorted. 1, 2, 3, 4, 5 is going to come. And for this, 1, 2, 3, 4, 5, 6, 7, 6, 6. 1, 2, 3, 4, 5, 6, 6 is going to be the smallest. Okay, so let's take some examples from this. So 1, 4, 3, 2, 2, 1, 9. So 1, 4, 3, 2, 2, 1, 9. All right, let me 1, 4, 3, 2, 2, 1, 9. Okay, and the k is, I think, 2, 3. K is 3. Okay, that's one example, and let's take another one. 10, 200. And let's say k is 1. And let's do 10, 200 again. 10, 200 or 10,200. And the k's value is 2. Okay. And then, yeah, let's go ahead and run this. Okay. So there you go. So you have, okay. So let's take a look at one by one. So these two we know. This is 1, 2, 1, 9, 4, 3, 4, 3, and 2 have been removed, so 1, 2, 1, 9. 10, 200 is basically 200, right? Removing 1 gives us 200, and then you have 10,200, removing 2 digits, make it smallest, and as you can see, if you remove 1 and 2, you only remain with 0, so that's why you get 0. All right, so that is how you can actually you can remove you can basically remove k digits from a string to make it the smallest string possible. Okay, so hope this video helped you understand the problem and basically how to go about building an algorithm to solve it, and then solving it in the code. So I hope you guys enjoyed the video, and I'll see you guys in the next video. Thank you.